Alright, welcome back. This is the discussion for 6.5, which is on natural logarithms. So there's a few questions I want to cover here, so let's dive into them. Let's first look at number 3. 3 says, without the use of a calculator, evaluate the natural logarithm. So I've got this ln for the natural log of e to the 3x plus 1. And again, I can say there's a rule here that makes this quick and easy. Since my base is e and the base of the exponent inside the logarithm is e, those cancel out. But to go the long route, I can say this has to be equal to something. I don't want to call it x, because I already have an x in here, so I'm going to call it y. And essentially I want to figure out what y is, right? But if I rewrite this, the natural log has a base of e, and therefore I have e raised to this y is equal to e raised to this 3x plus 1. And it then makes sense that the y, which is a power of this e here, has to match the power of 3x plus 1, the power of the e over there. Therefore I can say that y has to be equal to 3x plus 1. That's one way of doing it, right? Another way of doing it is to use the power rule. I'll just get rid of this here. We have a rule that says the log base a of b to the c is the same thing as c multiplied by that log base a of b. Right? That is to say, if there's an exponent on the whatever's being taken the log of, that can come out in front as a multiplier, and it's out of the exponent, right? So I can do that here, but I have to be careful because the power is this entire expression of 3x plus 1, right? And so that whole thing comes down as a multiplier, and since it's a binomial, 3x plus 1, being multiplied by this now natural log of the e, right? I have to throw it in parentheses, right? But the natural log of e is 1, and this is that cancellation, right? Because the natural log has a base of e, this is like saying what power of e is e, and that's 1, it's the first power, right? And so this simplifies out, that's just 1, and so this ends up being 3x plus 1 as well. Good. Let's look at number 8. Number 8 asks us to graph, and so we're going to graph y equals the natural log of x plus 3. Right. And again, I can rewrite this as an exponential, right? This natural log has a base of e, so if I take this and say this is e to the y is equal to x plus 3, I can subtract 3 from both sides. This gives me e to the y equals e to the y minus 3 equals x. And now I have this whole thing as a function of y to determine some x values. I can throw in values. I can say what happens when y is -4, -3, -2, whatever you want to plug in there. I'm going to get these values and then take them as e to that power and then subtract 3 from them. Right? So let's just do our standard. I'm going to go -2, -1, 0, 1, and 2. And so if y is -2, this gives me e to the -2 minus 3. But e to the -2 is 0.135 and then minus 3 equals -2.86. Right? Now if you're graphing this on paper, it's highly unlikely you're going to get so accurate that 6 matters, right? But this first decimal point is probably important, right? But I'll go through that and do all that with all of these, so let me just take e to the negative 1, and then minus 3 gives me negative 2.6. And then e to the 0 is 1, so minus 3 would give me minus 2. E to the 1 minus 3 gives me negative 0.28 or 0.3-ish. And then e to the 2 is going to give me 4.389. So like 4.4. Somewhere around there. I can graph these with my x and y values. So if I do that, I have x is negative 2.86, so not quite to 3, right? And you can see here that even if I started throwing in smaller and smaller y values like negative 3, negative 4, negative 5, I'm always going to just get closer and closer to the line x equals negative 3. And so I have that asymptote off of there. At negative 2.86, so almost there, I'm at negative 2. At negative 2.6, so still pretty far over, I'm at negative 1. At negative 2, I'm at 0. At negative 0.3, so not very far over, I'm at 1. And then at 4.4, somewhere up here, I get to 2. So it's a pretty quick little yoink, just like that. But you can see if you compare this to the natural log, I've just shifted everything over by 3, right? This pivotal point here would typically have been at 1, 0. It's been shifted up to the left by 3 and ends up here. The asymptote gets shifted left by 3, and that's all apparent by this x plus 3. You shift it to the opposite direction of that. All right. Hopefully that was helpful, and I will see you guys next time.